Hi everyone, Tina here, and today I'd like to talk about the constant acceleration equations, more commonly referred to as the suvat equations. You'll usually first learn about this topic during year 1 of your A-level course. I'll go through what the suvat equations are first, and then we'll run through some examples. So here are the suvat equations. No matter what exam board you're using for A-level, you should be given these in a formula book. This is an extract from the Edexcel formula book, and it's underneath the kinematics section of the formula book. Kinematics is just maths describing motion of objects without any reference to forces. Now, we can only use these equations when we have constant acceleration. That's really important. And I'll go through what each of the letters mean now. So you've got S, U, V, A, and T. S stands for displacement. U stands for initial velocity. V stands for final velocity. A stands for acceleration. And T stands for time. You'll usually only be working with some of these variables at any one time, and it just depends on the question. So let's take a look at some examples. Example 1. A car travelling along a horizontal road passes a point A with velocity 21 meters per second and immediately decelerates at a constant rate. The car comes to rest 260 meters beyond point A. Find the magnitude of the deceleration of the car, giving your answer to 3 significant figures. Now for this question, the clue that we want to use suvat is here because it says the car decelerates at a constant rate. As soon as you see any reference to constant acceleration, you should be thinking about suvat. With any mechanics question, I always recommend you draw a rough sketch or diagram of what's going on first. So in this case, we've got a car traveling along a horizontal road. So that can be the road, and then this can be the car. It passes a point A at 21 meters per second. And in my diagram, I'm going to assume that it's traveling to the right. So I'm going to put a double arrow with an A there for acceleration. The question references a point which is 260 meters beyond A. So I would put that on there, something like this. And that's all we're given. So now we're ready to write down suvat and fill in what we know. So S, U, V, A, and T. In this case, we want to know the deceleration. So I'd put a question mark next to the A and then see what else I could fill in. So we know displacement in this case is 260 meters. Initial velocity is 21 meters per second. It then says the car comes to rest. So that's going to tell us that the final velocity is 0. We're not given anything about time, and we're also not interested in finding the time, so we can put a cross next to the T. Now we need to go to the formula book and find the suvat equation that does not reference T, and in this case, that is this one. V squared equals U squared plus 2AS, no reference to T. And then we can just sub in our values and work out A. So we've got 0 squared equals 21 squared plus 2 times A times S, which is 260. You can then expand and rearrange this. So you get 520A equals negative 441, means A is negative 441 over 520. As a decimal, minus 0.84807, and so on. They want it to 3SF, so we can round here. Approximately minus 0.848 meters per second squared. And then finally notice that this question wants us to find the magnitude of the deceleration. So it's deceleration because it's negative, that's good. However, the magnitude would just be the positive version of that. So magnitude of deceleration equals 0.848 meters per second squared to 3 significant figures. Example 2. A train moving with constant acceleration passes through 3 points A, B, and C, where AB is 40 meters and BC is 60 meters. The train passes through A with a speed of 10 meters per second and 6 seconds later passes through C. Find, and then part A, the acceleration of the train. So first of all, let's draw a diagram again. We've got a train moving along a track, so that can be the track, and then this can be the train. Any diagram will do. Let's say this is point A, point B can be here, and then we'll put point C there. We're told AB is 40 meters and BC is 60. In my diagram, I'm going to assume the train is going to the right again, so double arrow for acceleration. We're also told that at A, the speed is 10 meters per second, and we're told that it takes 6 seconds to go from A to C. When you have your diagram ready, you can go ahead and write down suvat. So for part A, we've got S, U, V, A, and T. We want the acceleration of the train, so we'll put a question mark for A. And then we've got to think about which part of the motion would be most useful to work with. And I think we have the most information between points A and C. Because, for example, we know the displacement between A and C is 100 meters, and the time also is 6. We also know that the initial velocity is 10. We don't know the final velocity, but that's okay. We've got enough variables to work with. We now look in the formula book for the right equation to use, and we want the one that does not involve v this time. So that will be this one. S equals ut plus half at squared. We sub in our values. We expand, simplify, and solve for a. We get a equals 20 over 9, which is roughly 2.22 meters per second squared. And that's to 3 significant figures. Unless stated otherwise, 3 significant figures is good for exam questions. Part B, we want to find the speed at which the train passes through B. So in this case, we probably want to consider the motion between A and B. Then we write down suvat. The displacement between A and B is now 40. U is still 10. V is what we want. A now, we could use our answer from part A. We now know that the constant acceleration is 20 over 9. T we don't know, but we also don't want to know, so that's fine. And then we find the formula that does not involve t to use. And in this case, it would be this one. V squared equals u squared plus 2as. V is what we want. V squared equals 10 squared plus 2 times 20 over 9 times 40. If you type that in, you get v squared to be 2,500 over 9. Therefore, v is going to be the square root of that. Technically, the positive or negative square root, and that works out to be plus or minus 50 over 3. The 3 significant figures plus or minus 16.7 meters per second. Now, in this context, the positive velocity makes more sense, so we would give our final answer as v equals 16.7 meters per second. Now we're on to part C. So they want to know the time it takes for the train to move between B and C. So in terms of the motion we're interested in, let's look at the motion between B and C. Suvat again. What do we know? So we know displacement between B and C is 60. We actually now know the initial velocity because we know that the velocity at B was 50 over 3 from part B. Therefore, that is the initial velocity for part C. Final velocity, don't know, don't care. Acceleration, once again, is 20 over 9. And t is what we want to know this time. Once again, the suvat equation without v in it is s equals ut plus half at squared. So that's the one we want to use here. We sub in our values. We can expand. And then it's looking like we have a quadratic. So it's a good idea to rearrange it into a more normal form for a quadratic. So something like this. And then we can solve it, for example, using the quadratic formula. When you do that, you get 2 answers for t. One is t equals 3. The other is t equals minus 18. Now, in this context, time cannot be negative, so this minus 18 is invalid. And our final answer is t equals 3 seconds. I just want to go back to the wording of that question. Notice here it does reference constant acceleration again. That was the clue that we can use suvat. Moving on to example 3, it says a stone is projected vertically upwards with a speed of 18 meters per second from a point 2 meters above the ground. Find, and then part A, the greatest height reached by the stone. Now, there is no explicit reference to constant acceleration here, but if you think about it, gravity is going to come into play here. And gravity can be modelled as constant acceleration. It will be constant acceleration downwards. Therefore, we can use suvat again. And we always take acceleration due to gravity as g equals 9.8 meters per second squared, unless stated otherwise. Now, g equals 9.8 has been rounded to 2 significant figures. So for any questions where you use g equals 9.8, you should also round your final answers to 2 significant figures as well, unless stated otherwise. Let's make a diagram for this situation. So we've got a stone being projected vertically upwards from a point that is 2 meters above the ground. So let's say that's the point. Here's the stone projected upwards, and then it's going to fall back down to the ground. It's projected with a speed of 18, so we can pop that on there. And as we mentioned, acceleration is downwards due to gravity, so we can put A or G there, up to you. Let's focus on part A now. So it says we want to find the greatest height reached by the stone. So in terms of where we're looking on our diagram, we're starting here, and then here is the greatest height. So focusing on the pink part of the diagram for part A, whenever you're dealing with gravity, you want to choose a direction to represent as positive in your numbers. And in this case, I'm going to choose upwards to be positive. This will affect how we represent the numbers now. If we write down suvat, we want to know the greatest height, so we'll put a question mark for S. We know that the initial velocity upwards was 18, so we're going to use plus 18. At the greatest height reached by the stone, velocity will in fact be 0. So greatest height, v equals 0, because if you think about it, if a ball or a stone or a particle is travelling upwards, at the top of its journey, it's going to momentarily stop and then fall back down. Now, A, acceleration due to gravity, is actually going to be minus 9.8 in this question because we're taking up to be positive. So anything traveling downwards or anything going downwards will be negative. Time, we don't know and we don't care, so we can put a cross there. And then we get the equation, suvat equation that does not involve t, which is here. And we sub in. We expand and rearrange for S, and we get S equals 16.53 and more, which is roughly 17 meters to 2 significant figures. 2 significant figures because we're using 9.8. Let's move on to part B now. So part B wants the speed at which the stone hits the ground. So for part B, you may be referencing a different part of your diagram. In fact, we're more interested now from the beginning of the particle's motion to the end when it reaches the ground. Again, I'm going to take up as being positive. You can do it either way, it's up to you. And I'm going to do SUVAT. Now, if we're focusing on where the particle leaves the point at which it's projected to when it goes down to the ground, that displacement will therefore be minus 2 because it's going to end up 2 meters below where it started. U is positive 18. V is what we're interested in finding. A, once again, is minus 9.8 and T is don't know, don't care. We're going to use V squared equals U squared plus 2AS again, and we're going to sub in and solve. We get V squared is 1,816 over 5. V is going to be plus or minus square root of that, plus or minus 19 to 2 significant figures. But in this case, they just want the speed, so that will be the positive version. Speed equals 19 meters per second. And that's once again to 2 significant figures. Part C, they want the time between the instant the stone is projected and when it hits the ground. So again, we're interested in the blue part of the diagram. Going to take up as positive again, and I'm going to write down suvat. Again, S would be negative 2, U is 18. V we actually do know from part B, but I would be tempted to leave that blank just in case in the exam I made a mistake in part B. A is minus 9.8 and T is what we want to find. So we're going to use this suvat equation, which does not involve V, and we're going to sub in and solve for T. Once again, probably best to rearrange so that it's in its usual quadratic format, so you can solve it however you wish, and you get 2 answers for T. T equals 3.781 or T equals minus 0.107. Once again, the negative time is invalid in this context, so our answer is T equals 3.8 seconds to 2 significant figures. Last example. A particle is projected upwards from ground level with a velocity of 35.6 meters per second. How long does the particle remain at least 15 meters above the ground for? Once again, this question involves gravity, so we are going to use suvat. And remember, we use G equals 9.8 meters per second squared, unless stated otherwise. Let's draw a diagram for this. So we are projecting upwards from ground level. So it starts here and then it goes up and down again. Initial velocity, 35.6 meters per second. And this time we're interested in when the particle remains at least 15 meters above the ground. So if that's 15 meters, we're interested in this part of the motion. Let's set up our suvat. So again, I'm going to take up as being positive, but you can do down if you want to. I'm going to write SUVAT, and the displacement I'm interested in is 15 above ground level, so positive 15. Initial velocity, positive 35.6. Final velocity, not interested. A is minus 9.8, and T is what we are interested in. So we want to get the suvat equation that does not involve v, which is here, and we're just going to sub in our values and solve for t. Just going to expand those last brackets to make it easier to see and rearrange into a nice quadratic. Solving, as expected, we're going to get two t values, and in this case t is 6.816 or 0.449. Think about why it makes sense that there are two t values here for when s is 15. That must be at these points. So this point when it first reaches 15 meters, and then this point when it comes back down to 15 meters, all relative to its starting point on the ground. So to answer the question, how long does it remain at least 15 meters above the ground for? All we need to do is subtract those two times. When we do that, we get 6.37 seconds to two significant figures. And that's it. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else who you think might find it helpful. Thanks. See you next time.